Woohoo, welcome back. Today we're going to be working on the second half of 1.6, and these are problems that do look like they're quadratic, they're just a little bit off. So in other words, they follow the same pattern, but they're not quite quadratic. What do I mean by this? Well, basically our basic quadratic form is ax squared plus bx plus c. So something squared, something regular, and just a constant. And that's going to be equal to 0. And the idea is this actually can be expanded to the point where it's something times anything squared plus something times that thing again plus c. So if we use colors, we could say whatever is here gets squared, and then again it just sits there by itself, and then we add a constant and we set the whole thing equal to 0. And this would be quadratic type equations or equations of quadratic type. So here's the first one. X to the fourth minus 5x squared plus 6 equals 0. So why do I think this is a quadratic type? Well, x to the fourth can be seen as x squared squared, and 5x squared is just 5 times the quantity x squared, and then plus 6 equals 0. Now this is a quadratic type because basically what I've got is something squared minus 5 times the something plus 6 equals 0. And I can use blue to represent the x squared. Now you are also welcome to use another letter. So for example, frequently people use the letter U or even M to represent the x squared. So you could look at it as, you could say, well, if you let U equal x squared, then, let me do a dotted line there so you can see that this is kind of a different way to look at it. Then we've got u squared minus 5 times u plus 6 equals 0. So you can look at it either as being just seeing it as a quadratic type like this, or actually doing a substitution. It works either way. And either way, we're going to use, we're going to use the quadratic formula. So in this case, we've got blue thing, or you could say u. And then we use the regular quadratic on this form, not this form, but this form. So where we've got a equals 1, b equals -5, and c equals 6. So we've got the opposite of b plus or minus radical b squared minus 4ac all over 2a. And if you haven't memorized that yet, be working on it for sure. Totally. So we're going to get the opposite of b, so the opposite of -5 plus or minus radical -5, the quantity squared, minus 4 times 1 times 6, all over 2 times 1. Okay, so let's see. I think I get 5 plus or minus radical 25 minus 24 all over 2, which is 5 plus or minus radical 1 all over 2, which is 5 plus or minus 1 over 2, which is 5 plus 1 over 2, or 5 minus 1 over 2. So that is 6 over 2, or 4 over 2, which is 3 or 2. And at which point you go, yay, we're done. And then I say, no, we're not. And you say, oh, why? We did the quadratic formula. Everything's fine. Yes and no. So over here, we've got little blue square, or u, whatever you're using to create that quadratic type. But what is that actually equal to? And what it's actually equal to, whether you use the little blue square or you used u equals x squared, this is x squared over here on the left. So we've got x squared equals 3, or x squared equals 2. So if x squared equals 3, that means that x equals plus or minus radical 3. Does that make sense? And if x squared equals 2, that means that x equals plus or minus radical 2. So our answers, let's see, where do I have space? I'll put it up here because I've got a little bit of space. Our answers are actually radical 3, negative radical 3, or the opposite of radical 3, radical 2, negative radical 2. Now the good news is if we count them up, 1, 2, 3, 4, we've actually got 4 answers. And it's an x to the 4th. So it matches. We've found all the answers this way. The other question you could ask is, wait a minute, if I see this pattern where it's 1, or here 1x squared minus 5 times something plus 6, I could factor that. You absolutely could. So if instead of using the quadratic formula, you wanted to factor it, that would be fine as well. So you've got that choice. Woohoo? Yay, woohoo. Okay, next up. You guys ready? Dun dun dun! Okay, why did I dun dun dun? Well, I dun 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 because this has a radical in it. So even though, yes, this is going to be quadratic type, whenever we're dealing with radicals, we're probably going to be squaring something. Whenever we square something, we're going to forget about our pluses and minuses, which means that our answers are likely to have problems. So we want to go very carefully, go very simply, and just carefully and slowly. Okay, so first off, if you're looking at this and saying, okay, that's x minus 5 radical x plus 6 equals 0, okay, fine. That's not quadratic. And I would say, no, it's not. This is actually a radical equation, in fact. However, see the way it's written with 3 terms? So you could approach this like a radical equation, like we were doing in the first video. That would be fine. But given the way that this is written out with the trinomial like that, that strikes me as looking a lot like the quadratic form. And in fact, can I convince you? I'll write it as a fact. That way I don't have to convince you. I just say it is true. The square root of x, or radical x squared, is x. Do you agree with me? Hopefully you do, because it's true. I'm not trying to trick you. Yep, that's true. So in other words, where I've got this x right here, x minus 5 radical x plus 6 equals 0, this is actually radical x, the quantity squared, minus 5 radical x plus 6 equals 0. So in other words, yet again, I've got a quadratic type equation. Not actually quadratic, because again, there's a square root, so it's a radical equation, so it's something else, but it follows that same pattern. Does that make sense? So I've got something that looks quadratic. In the same way, just in a different direction, this one had x squared squared and minus 5x squared. This one has radical x squared minus 5 radical x plus 6 equals 0. So, how do we solve this one? Well, the exact same way. Either you can use the quadratic formula, which is what I'm going to do, or you could factor it as well. I'm going to use the quadratic formula just so you can kind of get used to seeing it. So over on the right-hand side, I've got the opposite of b plus or minus radical b squared minus 4ac all over 2a. Okay, so the opposite of b would be that opposite of negative 5 plus or minus radical b squared is negative 5 squared minus 4 times 1 times 6 all over 2 times 1. If you're starting to say, wait a minute, you picked the same numbers for this one, I would say, yes, I absolutely did. So it's a little bit familiar now, right? So we've got 5 plus or minus radical 25 minus 24 all over 2, which is 5 plus or minus radical 1 all over 2, which is 5 plus or minus 1 over 2, which is 6 over 2. or 4 over 2, right? So we've got the two answers, 3 or 2. Now, here's the question. What's on this side? It's not just x. It's not always just x. It's whatever goes inside this pattern. And what is inside this pattern is radical x, not x. So if I know that radical x equals 3 or 2, then that means that radical x equals 3 or radical x equals 2. So what is x? Well, if this is the square root of x is 3, then x must be 9 or 4. But we know something. And what do we know? We know that whenever we square stuff, we end up creating answers. So sometimes we're going to have extraneous answers. Might both of these work? It's possible. Seems likely we should probably check them though, right? Yeah. Okay, so let's go ahead and check. I've got x minus 5 radical x plus 6 equals 0. This is the original problem. Always check the original. Don't check one of these versions. Always check the original. And we want to check x equals, what were our two answers? 9 and 4. So let's check 9 and 4. Okay, so over on the left, where x is 9, I've got 9 minus 5 radical 9 plus 6 equals, we don't know, maybe it does, 0. So let's do 9 minus 5 times 3 plus 6. So that's 9 minus 15 plus 6. Now, do you know how to add this together? The pluses add together. 9 plus 6 is 15. Minus 15 equals 0. Yep, that works. Yay! Okay, let's try this one out. 4 minus 5 radical 4 plus 6. Does that equal 0? So that's 4 minus 5 times 2 plus 6. So that's 4 minus 10 plus 6. Okay, so that's add the positives. 10 minus 10, that equals 0. Oh my goodness, both answers work. So then we go to our original answer right here. And we can box them both. They're both actual solutions. Might one of them not have worked? Yes. Might both of them not have worked? Possibly. So you got to check them. Woohoo. Okay, so you guys are amazing and incredible and wonderful. So woohoo and math on, and I'll see you in the next video. Yay! Woohoo.